This is day 2 of the review of 5.1 to 5.3 part 1. We are going to review more graphing and other topics from this school year. Here are a couple graphs for us to graph. We want to graph first the left example, and we want to identify 3 points on the graph. So right now we have an equation that's in standard form, 2x plus y equals 6. So we want to first convert this to slope-intercept form. So we're going to subtract 2x from both sides. And then I'm going to put my slope first, then my y-intercept. And now we're set to graph it. Remember, this is the slope. Its slope is negative 2 over 1. So we're going to rise down 2 and run 1 positive. This represents my y-intercept, where it touches on the y-axis. So we're set to graph it now. So the y-intercept is 6. So we're going to go on the y-axis up 6 units. So over 0, up 6. Then we're going to do our slope. So we're going to go down 2 and right 1. Down 2, right 1. Down 2, right 1. We have some points now that we can identify. This point is 1, 4. This point is 2, 2. There are 3 points on my graph. Now I can go ahead and draw that line. Let's come over to this function. This function is an absolute value function. Remember, absolute value functions for a parent function are in the shape of a V. Here we have a transformation. We want to identify its critical point. Where is it moving? So remember, when it's inside the function, you think opposite. So we're going to move left 5, and then when it's outside, move down 4. So the critical point for this problem is negative 5, negative 4. So let's graph the critical point. We're going to go left 5, 1, 2, 3, 4, 5. And then down 4, 1, 2, 3, 4. So our point for our critical is negative 5, negative 4. And then remember the shape of that absolute value function? It's 1 right, 1 up, and then right 2, 2 up, and then it just follows that same symmetry pattern. And there is the shape of my absolute value function. Again, we want to remember what the ordered pairs are, so you identify a couple more points. So negative 4, negative 3, negative 6, negative 3. Let's move on to inequalities. We haven't done these in a while, so you might want to write these down. Let's start with the left example. We want to solve that equation, or that inequality for x. So we want to solve by undoing. So let's first distribute the negative 2 through. So we have 7x minus 15 will stay, and then we get negative 2x, negative 6. Then we want to combine like terms. So I'm just going to add 2x to both sides so that my x's will both be on the same side. So my 2x and negative 2x will cancel. 7x plus 2x is 9x. Then I'm going to add 15 to both sides. So I'm left with 9x on the left, and then negative 6 plus 15 is 9. Last step is to undo that 9 times x. So we're going to divide both sides by 9. So the 9's will cancel, and we're left with x is less than, and then 9 divided by 9 is 1. Now we can graph that inequality. That inequality has an open circle at 1, and how you say that is x is less than 1. That is to the left. We're going to go over to the right side of this smartboard and solve the other inequality. Alright, this is a compound inequality where we have two inequalities going on in one problem. So let's start with the left inequality. We're going to solve that for x. So we'll add 2 to both sides. So we have 5x is less than 3 plus 2 is 5. Then divide both sides by 5. The 5's will cancel on the left. 5 divided by 5 is 1. And we'll come over to the other one. We will add 6 to both sides. We're left with 2x on the left. And then 4 plus 6 is 10. Now we'll divide both sides by 2. X is less than 5. We'll put the word or in between and graph that compound inequality. So when we graph this compound inequality, let's start with the blue one. The blue one is saying open circle at 1. And how you graph that is x is less than 1. The green one is saying x going to 5, open circle, and x is less than 5. So it just kind of goes through the blue one and then moves on. All right, let's go on to absolute value inequalities. When you solve absolute value inequalities, you have to think about what's inside. And you can have two possibilities, a positive or a negative. So I would recommend that you do one of these two examples and write it down. And maybe watch the second one. All right, so let's start with the first one. It's the absolute value of 2x minus 7 is greater than 14. So we have to think about the positive scenario and the negative scenario. So I'm going to break up this into 2x minus 7 is greater than 14, or the negative scenario is 2x minus 7. And remember what happens? We have to flip the inequality and flip the sign. So the inequality changes to a less than, and then the 14 changes to a negative. Now I have a compound inequality that can solve separately. So I'll start with this one. Add 7 to both sides. So I'm left with 2x is greater than, and then 14 plus 7 is 21. Then I'm going to divide both sides by 2. So I'm left with 21 divided by 2 is 10.5. Now we'll come over to this one. Again, add 7. And then negative 14 plus 7 is negative 7. Divide by 2. X is less than negative 7 halves. So let's go ahead and make a number line. We'll just do rough numbers here. Not liking my pen here. Let's try one more time. All right, let's go back to our pen again. So here's 0, and then we'll just go 2, 4, 6, 8, 10. And then this way, negative 2, negative 4, negative 6. So let's graph the first one. X is greater than 10.5. Put it up there. And then this one, remember negative 7 halves is negative 3.5 if you want to convert that to a decimal. So negative 3.5 is about here. And then as x is less than negative 3.5, so it's going to be the left. All right. Like I said, if you've already written this one down, I'd probably say you can just listen and watch on this one. So we have another absolute value equation, inequality. Before we split it up, we want to divide by 2 first. And then we're left with the absolute value of 5x plus 3 is less than 6. Now you're at the same place as this example on the left. We break it up into its positive scenario and the negative scenario. 5x plus 3 is less than 6. Or 5x plus 3 is greater than negative 6. Notice the two things that happen over here. The sign changes and the sign changes. And then you just continue the problem solving for x, and then graph that on the number line. All right, let's move on to, I'm going to stop this recording. It's about 13 minutes, and we just have graphing systems left.